Hi, everybody. How are you doing? I'm okay. Getting over a little cold, but surviving. It was good. I taught a class on Friday. And actually, no, Saturday, my non-credit course. We're finishing next week, or this week, actually. Can't wait till Thanksgiving, though. Getting to eat food and relax a little bit. So in a few minutes, I'll talk about our plan for the next few weeks, as today is our last lesson. Yay, you guys made it to the end. We just have to finish the project, the final review, and the final exam that's left. We have one more quiz. So let's see. So today we're gonna do the relations chapter. Yeah, people kind of drop off on Zoom. I'm glad. Well, I like to make sure that the students understand, so I do have a little bit of a requirement with the lecture, but after this week, it's not mandatory anymore, right? So I'll talk about how we will cover the final review, so you can show up if you like. But we still have until December 17th is our last day. That's the final exam. I hope your project is coming along. Or if you haven't started on it, start thinking about what you need to do. Okay, so it's 6 p.m. I'm gonna go ahead and get started. I'm getting over a little bit of a cold, so sorry if I'm gonna start coughing or sneezing. But today is our last lecture. You will not have to log in to Zoom on Thursday for lab. We have a discussion thread for the lab in place of the lab this week. So if you just complete the discussion thread by the end of the week with, the main response and 2 reply, then you're golden, okay? And I want you to use the time that you have to catch up with any work that you miss. And if you're all caught up and you're in a good shape, then I want you to start working on your project. Get that done so you don't have to scramble at the last minute because, you have other classes, I understand. Okay. Now, if you have any questions, if you wanted to meet with me during our scheduled time, let me know. I will hop on Zoom. We can use the same link and then I can address some of the questions that you have for your project maybe. So that's, so I leave it kind of like, open session if you wanted to meet. If you feel like you're able to handle the project on your own, right? Or if you want to just email me if you have questions, that would totally be okay too. Okay. So I'm going to go into screen share real quick and I want to talk about the schedule and the upcoming things. So what we have is this week, we're gonna finish up with the last chapter, which is on relation. So that's today. We're gonna complete the assignment so you can submit that this week. And I have a discussion thread called Automata Theory in computer science. And I wrote the description of automata theory here. So I want you to read it, right? And what I want you to do is pick one of the 4 families, okay, of automata and explain, right? So simply once you pick the topic, like let's say that I pick finite state machine, I will research it. And in the main thread, you're just gonna describe, right, what you have found, what it is, explain how it impacts today's computing architecture and development. And if you have any sources that you use, you want to include that at the end. So give me like 2 paragraphs on it. And so if you can post that by Thursday so other people can respond. After you have a main post, just reply to 2 people. Don't just put I agree or I disagree. You know, give it a little bit of a concrete response. You know, ask questions, things like that. So I want to have some interaction. As you know that this class is going to lead to additional upper division classes. So when you transfer, they will touch on the topic with Automaton, right? So as you know that the models are still being used in a lot of different areas of development. The common topic that a lot of students like to pick is the Turing machine. Whatever you like, you can research it. You can give me a description on it and explain how it's being applied in today's development for architecture, okay? So that will be the lab requirement for this week, is to post the responded to the discussion. This thread is going to be a lab grade, so make sure that we complete that, okay? So we don't need to meet on Zoom on Thursday. You can do this unless if you like to schedule something with me, like let's say you want to pop in on Thursday on Zoom because you have questions or your team has question about the project, I'll be happy to do that. I'm available. Or if you wanted to schedule something outside of class, right? Just make sure you send me an email. Then after this week, okay, I'm going to release a quiz that's going to cover all the later chapters that we have gone over. And you're going to have one last opportunity to do the extra credit quiz review for quiz 3. So it's going to cover chapter 5, 12, 13, 16, and 17. And it's a short quiz. So what you will do is you can just next week, you can just log in and do the quiz. I will also post final review. It will be 2 parts. Okay, they're kind of long, so I broke it up into half and half. What I will do is on the 1st of December, I will go over part 1. Okay, so look at the assignments. That's going to be a homework grade. Okay, part 1 and part 2. The reason why I require it is I want to prepare you for the final exam. We've talked about a lot of different topics, so I want to make sure that you're going to be ready for the test. I know that most of you are, but it's just good to do some review. And then so if I'm not able to finish on the 1st, what I'll do is on the 3rd, 2 days after that, I'll do the part 2. So during that week, if you want to log in and if you want to go over the final review with me, so just like how we've been doing the in-class assignment, I will go over the questions. I will address any concern you have with specific questions. So that will be part 1 and part 2 during the first week of December, the 1st and the 3rd, okay? And so then I will release my own course survey at the end, so you can do that later on. But in the meantime, make sure we work on our course project. Now, you know that the school is not gonna hold class sessions during the week of 23rd to the week of that week, the 23rd through the 28th. We have no class session because of Thanksgiving. So, you know, basically there's no class there. So next week, there's no Zoom requirement. The first week of December, I will go over the final review. I won't take attendance after today. So today there will still be attendance, but I will have no attendance requirement after that. For the final exam, I will likely use Lockdown Browser. So make sure that you think about that and how, you know, the computer that you use. So it works on Windows PC and it works on Mac OS, like if you're using a MacBook or an iMac. On the Chrome, some of the students, the Chromebook, some of the students, they had challenges last semester. So what you can do is you can also borrow a laptop from school if you want to take the final, or if you have a second computer, you can use that. I will release the information on how to use Lockdown Browser during that week. And the final will be activated on the 17th, okay? You have the entire day to do the final. So, you know, it's 50 questions, multiple choice, very similar to what you had on the quizzes. So if you finish, right, it will score you and then it will put that onto Canvas. The project is also due on the last day, which is the 17th, which gives me a few days to go over the project. I hope to finish everything by the Monday or the Tuesday before Christmas. So hopefully I'll get everything done by the 21st and put your grade into your web advisor so you can see your transcript. As some of the students, I know that they're transferring for the winter, so I want to make sure that I get that done and send that through. And they do only give us a few days before the holidays. Okay, and then after that, you have a little bit of a break. If you're taking winter courses, that's going to start at the beginning of January. And I'm teaching Python and Python and CIS18A, which is Java in the winter. So in case if you have any questions or anything after the course is closed, you should still be able to see your Canvas shell and look at your grade. You cannot submit anything else after the 17th on Canvas. However, if you have any questions, you can always send me email. And then after the courses, let's say you move on to, you know, CSU or UCs, you transfer school. On my profile, I have my LinkedIn, so you can always LinkedIn with me in case you have questions or ask for a letter recommendation, or you can also send email, okay? But give me some heads up before, you know, if you put me down as reference and stuff like that, because sometimes I get a link from somebody and then I don't know what that's for. So just if you wanted to put me down for reference or ask for a letter recommendation, give me at least a day so I can give that to you, and I will send you a copy, or I can upload that copy for what you need. Okay. All right. Any questions? Okay, so I see some chat here. So before, I thought, let me fix that. No, so we're doing the week 12. Let me see if there's a wrong due date on here. I did save it yesterday. Yeah, so unit Unit 12 is what we're doing today. And sorry, this is mislabeled on the top. Let me fix the module. Let me drag this. Let me edit the module. This should be set 12. Sorry about the confusion. So you are going to do Unit 12 in-class assignment. This one is due in 2 days, so you have until November 12th. I thought I was high on Theraflu last night, but I did it right. Sorry. But yeah, Unit 12 is due on the 12th. And then the homework, there's a homework for the quiz review that's due on the 15th. So that's going to help you prepare for your quiz. And then your quiz is going to be open next week. So for the entire week. Okay. All right. So we are going to address Unit 12 in-class assignment today. Last week was Unit 11. Okay. All right. So I fixed the module name. So let's see anything else on the chat. Oh, for the discussion. Oh, thank you. Thank you for pointing that out. Let's fix that right now since we're here. Let's make it to Sunday. Oh, not the 8th, the 15th. That's what I want. Okay. So we're good now. So I fixed the due date for that. So you have until Sunday to post everything. Sorry about the confusion. Okay, so I graded the assignments that you submitted. If you submitted and you didn't get the grade that you wanted, it's possibly because of attachment or something had gone wrong there. So read my comment. And then I still have to grade some of the project that was submitted. So I'm going to work on that tomorrow. All right. So let's talk about the last chapter. Okay. And you can download the chapter 17 notes. So in this one, we're going to talk about relations with the objects and of the two sets. So sometimes they could be identical, sometimes they're not, right? So it's a way that we would have established some kind of connection between the objects. And so it says that relation may exist between objects of the same set or objects of the two or more sets. So you can have 3 sets, you can have a lot more, right? So what we wanted to do is we wanted to look at how a group of numbers can relate to the next group of number. Sometimes we would see subsets that would have relations within that set. So when you begin looking at the relations in the sets or the objects, what we can say is that we can start looking at the domain and the range, right? Like very much in algebra, we can say that domain would represent the x values, which are independent. The range would represent the y value, which is dependent. So when we graph that, right, the x we would move horizontally, we can plot that. And then with the y from that horizontal location, we would move up and down for the y. So the range would be dependent values. And what you would see is that x and y can represent, it's part of the real number, which is a set, right? So you can say x can be real numbers and y would be real numbers as well. So in the first example, it tells you that set A, you have 1, 2, and 9. And then set B, you have 1, 3, and 7. Okay. So first, we're going to take a look at the number 1 here in set A and the number 1 in set B. So we can say in case 1, if relation R, if the relation, we call that R, is equal, then we can say 1 and 1 is equal, right? 3 and 3 would be equal. But in set A, we only have 1 and in set B, we have 1. Okay, so for the domain, we would have to say in order for it to be equal, it needs to be exact. Okay, so it must be 1, 3 for the domain and 1, 3 for range. Okay. In case 2, if we need to compare and we want to say, oh, what if we're looking at less than relation, right? 1, 3, 1, 7, 2, 3, 2, 7. So we can say that 1 and 2, right, for the domain is less than, right, 1, 3, 1, 7, 2, 3, and 2, 7. Now for the range, we can say that 3, 7 is not less than, right, the rest of these. Okay, so basically you can use the value within the subset to do the comparison of the entire set. Now, if we're saying, if we wanted to look at the relation that's greater than, we can say 2, 9 is going to be greater than 2, 1. Okay, but it's not greater than the rest of these. Okay, and then for the range 1, 3, and 7, right? So is 1, 3, and 7 greater than 2, 1? 9, 9 here? No, right? So when you see this is when what you wanted to do is select the value that you're going to represent how we would be comparing to in the domain and the range. Okay, so let's look at the first question. In the first question it asks you, it says, determine the domain and the range for the following relation. 1, 3, negative 2, 7, 3, negative 3, 4, 5, and 1, negative 3. Okay, determine whether the relation is a function. Okay, so what I have is first, let's select the first number for each of the pair. So I highlighted in yellow the domain, right? So we're going to go ahead and list that. So our domain would be 1, negative 2, the first number in each pair, 3, 4, and since the set has to be unique, we don't need to list the other one, right? So we can say that 1, negative 2, 3, and 4 for our domain, because 1 is repeated for the last pair. Okay, then for range, we're gonna list the second number, which is y in that pair. So I highlighted in teal here, that will be 3 for the first pair, the second number for the first pair, 7, negative 3, and 5. Okay. Now, since we have the repetition in negative 3, we only need to list it once. Okay. So once I have the domain and the range listed, I can look at how that would be. Is there a function, right? And we can say that the function for it would be x is to y. Now you can go into the specific and you can say that, you know, is certain value less than or equal to, right? So we can say that, you know, x is less than y for the first pair and so forth, right? X is less than y for the second pair, x is greater than y for the third pair. So to sum it up for all, we can say its function is x is to y. Okay. Any question with number 1? So on the quiz, And the exam, we need to be able to identify which value is in the domain and which value is in the range, given the pairs. Any questions? Now, in the second one, sometimes you would see that it would be illustrated using shapes and diagrams. So on the left, right, we have these values in orange or brown. On the right, we have these values in the blue. So we will treat these as domain, right, as they are independent. And we would treat these in the blue as range because they are dependent of the domain. So you can look at this, right? And we can still have the same function. We would have f is x to y, right? As we would see that the value is from the x is pointing to the y here, from the domain pointing to the range. Then you can start listing. So we first would list our domain. We would have 3, 4, 5, 6, and 7 for x, pointing to y. Y would be 2, 3, 1, 9, 8, and 12. Okay. So when you approach these problems, what you should see is that number one, we need to identify which values are in the domain. And second, we need to identify which values are in the range and how we can draw the relationship between the domain and the range. Okay, very simple. This might be review for many of you, right? You probably learned this maybe in middle school or high school. Now you notice that the 8 here, right? It's not dependent on anything in the domain, right? So there, even though it's there, there's no relation for 8 to the domain, as 6 and 7 points to 12. So we can say 6, 12, that's the pair, right? 7, 12, that's the pair. 8 is not dependent on any of the values in the domain. Any question? Okay. So you would see something similar to this on the quiz and test, right? It'll give you a diagram looking like this. And then it's going to ask for things like what values is in the domain, what values is in the range. So if we wanted to write it as pairs, we simply use the arrow to go from domain to range. So in the first one, let me zoom out a little bit so we can see the complete picture. So the first pair we have is 3, 2, right? So we list that, and you can put that in parentheses as it would represent the pair. And then we would enclose all of these pairs into the curly brace. And then we have 4, 1 is the next pair as we follow the arrow here. And then next we would have 5, 9. And then after that, we would have 6, 12, and 7, 12. So the 3 and the 8 in the range has no dependency to the domain. Okay. Question. Okay, no questions. So next, we're gonna go ahead and look at the given values in number 3, and we're gonna look at the relationship. Okay, so it says let A equal to 2, 4, and 6. B is 3, 5, 7, and 9. Note the condition for R, where R represents relation. Is it equal to, is it greater than, or is it less than, right? So if we're looking at 2 compared to 3, right, then we would have A is less than B, okay? If we're looking at 4 compared to 5, we would have 4 is less than 5, okay? Now, if you do 6, 7, I highlighted the 3 there because in the last semester, so let me cut this real quick. So if we do 6 to 7, right, as it is x to y, then it will be less than, okay? Now, if we have 6 is to 9, right, that will be less than, okay? So if we specifically say that A is less than B, if we're listing the pair, right, as you can see that 2 is less than 3, 4 is less than 5, 6 is less than 7, 6 is less than 9. Now, if it's not less than, what we can say is, what if we would do 6 to 3, right? That would not be less than, okay? Or if we're doing 4 to 3, that would not be less than, okay? So if we are creating these pairs from the given domain and the range, we wanted to see if is x less than y, right? So if I compare 2 to 3, 2 is less than 3 in that pair. So A is definitely less than B. Okay. Now, we would, if we just go sequentially down this group, right, down this set, we would do 2 to 3, 4 to 5, 6 to 7, and 6 to 9, assuming that 6 is gonna, 7 is dependent on 6 and 9 is dependent on 6, right? Given that set. Any question? Pretty simple, right? So we set them up as pairs and we can draw a conclusion based on the comparison. How is x to y, right? Okay. So going back to our notes, sometimes, as we talked about graph last time, sometimes you would see it being represented like this, right? You would see little diagram that would have shapes and arrows to draw to illustrate one object being related with the other object. And in this case, we see a directed graph where you would have different relationship being shown. Okay. So in this one, what you see is when it is represented itself, right, where it would be the exact same values, then it becomes reflexive. Okay. And sometime we would have one object related to another object, which we've shown with the domain and the range. So we can have this related object A related to object B, B is related to C, etc. So now what we have to cover is we have to explain what would be the different types of relations. Earlier in the semester, we talk about a set. A set can be empty, right? Like you see this in programming. We can have a container doesn't have any initialized values, right? It would be an empty container and we can add in the values as we go. So in such case, if you have an empty set, right? Let's say that you have one empty set and another empty set, you would have empty relation. So if you have X and Y and they're both empty, you would have empty relation. Okay. Now, in other cases, we would have full relations where we would have values to represent X and Y. So you have set X and set Y, right? And there would be the function between X and Y. Now in C++, I think we use a lot of ways to represent an identity of a certain object, right? In Python, in programming language, in some languages, they would implement like identity operator, where you can really identify the location of that object and whether it would be identical or storing the same values as the other object. So in the third item here, we have the identity relation in which you have set X can be represented with a specific value, and X is part of a larger set, right? So an example of this, when I teach Python, I would tell my students, so let's say you have a string, and inside that string, you would have specific characters like A, B, C, D, E, F, G. And then you would have a subset, another string that would have A, B, C, D, right? And you wanted to see, you know, if that object can be identified with the larger set, original string A through G. So what we can say is that the small x here is an element of a larger set. Okay, so it would identify with the capital X, the larger set. Okay. Now with the inverse relation, in the inverse relation, that would be the opposite. So if you have one pair that's B and A, or X and Y, then the inverse of that would be the opposite, Y and X, or A and B in this case. Okay? So that will be an inverse relation. Now, when earlier we say that some can be exactly the same, which really means it's equal. So when we say reflexive, it could be something like this, 1 and 2, and then you have another pair that's 1 and 2, right? Or you can have 1 like this, 1 and 1. So what you have is they are exactly equal, so it becomes reflexive. Okay, so reflexive relation, it has reflexive property in which it is equal to itself. Okay, that's important to know. And the way that is drawn, it's usually something like this, right? It would show something like this. Like A is itself, right? Like in programming, we would say this object is equal to itself. A is equal to A, right? Okay, any question? Okay, so let's look at the next example. So you have 1 and 2 pair and 2 and 3. Then the inverse of this will be 2 and 1 and 3 and 2, right? So that would, when you see the R with the slash like this, okay, that means that it is the opposite or the inverse. So we can say that the opposite of that relation would be 2, 1 and 3, 2. So we flip them. Okay. And the relation of R on the set A could be reflexive, right? If it is identical. But since we show here that it's inverse, so that would be the relation as the opposite. Okay. Now, if we wanted to explore more on the reflexive, let's say that you have X is A and B. This is the set. How can we show that it is reflexive? It would be A and A, and then B and B. Okay. So now how is it not reflexive? Anything else, right? So if we have something like 1 and 1, right? And then another pair 2 and 2, for example, so that becomes reflexive. But if I have like 3 and 5, then it is not reflexive, right? This could be that X is less than Y, so we can say that it's less than. Okay, if it's identical like this, we can say that it is reflexive. Okay, any question? Okay, so let's go over a few more before we complete the assignments. Okay, so with this, then what you can say is that it would be symmetric. Okay, so the relation of R on set A is called symmetric, and symmetry just is a mirror, right? Like it's the exact same thing. So like last week we talked about cryptography. So when we have symmetric key, it's the exact same duplicate key to open and lock. So when we're looking at values, if it's symmetric, it is the mirror of it. So then you would have something like this. So let's say that we have set A is 1, 2, and 3. And we wanted to represent this where it would be either symmetric or anti-symmetric. Okay. So if we do 1 to 2 as that pair and 2 to 1, earlier we said that this is an inverse, right? The opposite of it. So when we flip the numbers, and 3 to 2 and 2 to 3 also is the opposite. Okay. So in such case, we can say that this is anti-symmetric because they're not exactly the same. They're the opposite. Now, also, if you wanted to represent something that would be transitive, let's say that you have 3 nodes, A, B, and C. So node A is equal to node B. Let's say that it holds the same value. Node B is equal to C, also holds the same value. Let's say I give A 100, right? And I would say that it holds 100. It is equal to B. That means that B holds 100. And B is equal to C. That means C also holds 100. So we can say that A is the same as B. So A is reflexive of B and B is reflexive of C. But since we're looking at the node from one point to the next, it becomes a transitive. So we can conclude that C would hold the same value as A. Okay, so in a transitive relation, you would see that it would represents the equal to relation across these nodes or these objects. Okay, so let's look at the diagram now, see if we can interpret this. Okay, so in the first one, for 4A, we can say that A is itself. That means that A is equal to A. That is, it would be reflexive. So the R here, right, the relation here is that A is reflexive as A is equal to A. Now in 4B, we can say that A is equal to B and B is equal to A. So it is symmetric. Okay. So let's say if we give A the value 5, and we can say A is equal to 5 and A is equal to B, that means that B is, it contains 5, right, integer. So A is equal to B and B is equal to A. So we conclude that the R here is symmetric. The relation, it has symmetric relation. Any question with 4A and B? So for quiz and final exam, you will be given something like this, and you will have to choose the choice that would represent the image that's given for to show the relation. Okay. Then for the next one, let me move this up a little bit so you can see. For C, we saw this in the example. We can say A is equal to C, and A is equal to B, and B is equal to C. So it is transitive. So if I have the value A contains, let's say 1, right? And I say that A is equal to B, that means B holds 1. And if B is equal to C, that means C holds 1. So therefore I can conclude that A is equal to C. So this relation, they have transitive relationship, A, B, and C. Any question? No question. Okay, let's move on to number 5. Okay, now in some cases, you're gonna see that we can write them out to show different type of relationship, right, in our set. So let's do this. Okay, so for number 5, it asks you, it says for each of these relations in the set 1, 2, 3, and 4, decide whether it is reflexive or symmetric or anti-symmetric or transitive. Okay, so we can say that the first one, 2 and 2, is reflexive. So I'll highlight that in yellow so you can see that they are reflexive. Now, when we look at 2 and 3 and 3 and 2, that would be anti-symmetric, right? Because it is the opposite. Or asymmetric, I should put. So I already had that there. So that would be asymmetric. So the reflexive ones are the identical one. 3 and 3, that's also reflexive. Okay. Now we can have it transitive. Why would that be transitive? Anybody know? So we have 2, 2, 2, 2, 3, 2, 4, 3, 2, 3, 3, 3, 4. So as we explained earlier, with the transitive is we would look at the relationship across the nodes. So we would have 2, 3, 2, 4, 3, 3, 3, 4. So we also have a transitive relationship for the last. Okay. All right. For B, we have 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, 4, 4. So we know that the identical ones, the 1, 1, 2, 2, 3, 3, 4, 4, they are reflexive. And then for these ones, 1, 2, and 2, 1, they are asymmetric. Okay. Any question? For C, number 5, this one is very easy. You saw them in similar ones in A and B. If you have 1, 1, 2, 2, 3, 3, 4, 4, they're just reflexive, also known as symmetric. Any question on number 5? And you don't have to highlight them like I did. You can type them out specifically and specify. So let's see, there's a chat question. Is C reflexive, symmetric, transitive? Is C reflexive, symmetric, transitive per our notes? So C would be reflexive, and therefore it will be symmetric because it mirrors, but yeah, I do see transitive in that. 1, 2, 3, and 4. Let me double check here. It would be symmetric. A turns into B, B and C. A then is same as C, and thus it is transitive. Since X is related to Y, Y is related to Z in the relation and the transitive. One, two, two, three. Relation is equivalence, relation reflexive. Yeah, but it doesn't have, it wouldn't be symmetric, asymmetric, transitive, 2, 3. Yeah, on the last one, since it doesn't have 2, 3, and so it doesn't have, so it will just be symmetric and reflexive. Yeah, so wouldn't transitive means that they share a common Y value. But these don't show that they share the common Y value, right? Yeah, so on the first one, the A here, right, you see that it's transitive there. And then on this one, it would just be reflexive and symmetric. Okay. Other questions? Okay, let's work on number 6. Determine whether the relation of R on the set of the integers is reflexive, symmetric, antisymmetric, or transitive, where X is to Y, and we wanted to see if X is greater and equal to Y squared. okay? So as we would start with unsigned integer, we can say let x is 1, y is equal to x if y is 1. So we would have 1, 1, right? 2, 1, 3, 1, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9, 3, etc. And if you wanted to represent x is greater and equal to y squared, we can continue that, right? So we can say 10, 9, etc. So here I just started writing out some of the pairs. First, the first one is x is equal to y, or x is equal to y squared. X is greater than and equal to, or greater than y squared, right? X is greater than to y squared, and so forth. I should change these. Sorry. Let's change them. So if we are at 2, so that will be 5, 4, right? 6, 4, 7, 4, and so forth. You can continue. So let's say if we have y is equal to 2, then we're at 4. So 5x needs to be greater than y squared. So 5, 4, 6, 4, 7, 4, and so forth. So in this case, what do we have? So we have the first one that would be reflexive. What about the rest of them? So that will be reflexive. What about these? Is it symmetric, anti-symmetric, transitive? Yes. So we can say that as they transitive. Okay. Now we arbitrarily put in x and y value with different values for the integers. You can represent that, the relations, different ways using different pairs, of course. Okay. So can I have the opposite? Not likely, right? It would not be anti-symmetric unless we would have x is less than and equal to y squared. Then I would have an anti-symmetric, but in this case, it's not. It's greater than or equal to y squared. Okay. Okay. Any questions on 6? Okay, let's look at number 7. Determine whether the relation R on the set of all integers, that is reflexive, symmetric, anti-symmetric, or transitive, where x is to y is, so if x is not equal to y, right? So here I put down the example, right? One case that we can look at is 1, 2 and 2, 1. So we have 1, 2 and 2, 1, right? X is not equal to y. So right off the bat, we know that it's irreflexive. It's not going to be reflexive as it will never be equal. It could be asymmetric, where it would be the inverse. Can it be transitive? Right, so if I have 3, 1, 2, 1, 3, 1, 4, 1, yeah. But, so we would have to continue to write additional pairs to show that it could be transitive. Okay, so because it's not equal, you would have irreflexive. Okay, any questions? So the last chapter is fairly short. It gives you some example to look at. Look at the example. I added some of the notes information, and also in the assignments, you can take a look at that. So there will be a couple questions on the quiz and the exam related to this, just to wrap up all the things that we talk about. But overall, the only chapters that we didn't cover, like I think 16 in the label book, this is chapter 17, 16, and some of the other chapter which we address in the discussion, because there's just a brief theory summary on automata. Okay. All right. So as I have a little bit of time, if you don't have any questions on the last chapter, I will touch on a little bit on how to use GitHub and tie that to your e-portfolio for your project. And don't forget, we're going to do final review. So I'll go over the questions and I will release the final review next week. So you can look it over. Okay. All right. So let me close this. I added GitHub how-to here. And if you missed last session, we added some team options for you. So if you like to join team, I created Microsoft Teams so that way you can communicate. But I don't require GitHub this time, but when you put stuff on ePortfolio the way Google has it, it doesn't really, you know, your code doesn't go in nicely like what you would have in GitHub. GitHub is really designed to share source code. So one of the things that I had helped the students with, and a lot of students get confused on how to use GitHub or they don't use it correctly, right? So when you access GitHub, if you haven't had an account already, you can register for an account. And then you can use GitHub with a lot of things. For this class, you can use it with REPL, right? REPL.it. You can also, you can also share your REPL link. But what you can do is you can create a repository, and in the repository, all that is that it would be a container where you can share your source code and information, and people can go in and download it and so forth. Now you can use GitHub to sell your program. They do have a marketplace where you can use that. And if you're into game programming, like development for game using Unity, right? Unity project now ties with GitHub. So when you download Unity or sign up for Unity Access, it actually asks for that. So you would start with creating a new repository. And in that repository, you would include information about your code, your program. Okay, here is mine. I use it just to demo for this class and other classes. So what you can do is, you can follow the instruction, but it's really easy. So once you sign up, it will ask you to create a project, and I'll explain the difference between project and just a regular repo. So up here, if you click the plus sign, you will find that you can create a repository. If you're using like an IDE like Visual Studio, some IDE will work really well with GitHub. So you can also import in your project from your IDE. And so forth. So if you wanted to create a new project, you can do that. So for a project like this class, you can just create a repo. And here you can name it. You can say final project or CIS7, right? And then you can give it a description, right? Like blackjack program in C++. Now, in order for other people to see, you would use the public. You can also choose to have it private. So if you want me to see your source code on here, or you want employers to see it, you would choose public, okay? Now, as they had improved this, you should add a README, and I put in the link for the README 101. It talks about what should go on a README. So just to sum it up, a README should contain who creates that code, what version it is, some brief description about that program, and if you have copyright information, you need to put that there, right? And everything is in HTML. So you have to format it, right? Otherwise, everything is in a huge long line if you don't have new line or line break, etc. So now let's say that I create a repo and I didn't put in a README file, right? What I can do is I can always commit a new file. So every time that you commit, that means that you make changes to your repository. It tracks all of that. And we use this mainly for version control and looking at how we can branch that and use it with other people, editing your code, etc. So it builds like a team programming environment. It does really well with that. So in the repo, as I created it, I would see that here, and it creates like a folder. What you can do is on the you can add in a file and be able to change that, right? So you can include a README. You can also upload your code. You can do a lot of different things to it. And so we can upload an existing file here. So if I wanted to make a file, I simply just click a new file here, right? And let's say that I want to make a README manually. I would just do readme.md. Now in GitHub, if you don't put in the file extension, it's just going to treat it like a text file. Okay. It's like a nothing file, right? Just a file. So if you wanted to create a file that would have, general information or a document. You can, when you upload your document, like from a docx, like from Microsoft Word, it will have that file extension. So here, let's say that, you know, I have a README file and I can just say Blackjack program in C++, and I can give it a description. And then I will put the author, right? And then I put the date that I created it. And then version number 1.1 or 1.0, whatever you like, okay? And if you are co-contributing to the project, you can put everybody's name. Now, when I commit this, what will happen is it's gonna be a huge long line, right? So if I want, I would have to format it, and I put in a link for you to learn how to format your GitHub. Now, I didn't require this for this class this particular semester, but I wanted to instruct you how to do this. So when you create your repo and share it with employers and, you know, colleagues, people in the field, it makes sense. So you should have a README file, and your README file should have general instruction or description about your program. And then information about the creator, the version, and copyright. So once I'm happy with what I have as a file, I just commit it. And what it will do is it will create that log. See, now it shows that it's a huge long line, so I can edit it by formatting the HTML. So now what I can do is, what if I wanted to add another file, like my CPP, right? My program file. So I can choose upload and find it on my computer. Or if I wanted to, just for some students, they have a hard time with navigating through the IDE to pull the source code. So if you can upload everything, or if you wanted to create a new file, you can just make a new file. So let's say that I would say this is blackjack.cpp, right? And then I can go ahead and add in my code here. You can copy and paste it, right? And then once you're done, you just click commit. And what that will do is it's gonna put in your code like this. Now we can organize it in subfolders, right? The majority of the people that you see on GitHub, they would have very much like what you have in Visual Studio or in IDE. You would have a folder for source code in that project. So you can organize it that way so it looks very professional, it looks nice. But it's okay to have it like this, because that I would have many different repository for many different things, okay? Now, what if I wanted to make a project inside this repo? I can. I would click here, right? And then I can go into the repo itself, and then I would be able to add a new project or click the link for the new project. So when you look at the projects, it's categorized a little bit differently. You can, it actually let you track your project status. It has like a planning component compared to a regular repository, okay? Now, at the university level, a lot of the professors, they expect you to know how to use GitHub, because this is what the community use, or you can use other form of version control based database that's like this. So, you know, you can set up, and some of them they teach from GitHub, like you have to get their program. I know that, you know, Lac Dallaire and some people in the district, they do that. You have to acquire the program from GitHub to be able to add or edit their program for the projects. Okay, so that's just a brief summary of how you would be able to navigate through GitHub. Now, this is my profile. So I have like different, as I demo through different classes, I have different repository created, okay? So what will happen is, let's say that I wanted to share this and link this to my ePortfolio, right? I would, so this is the link at the top right here. You can simply take this link, and the way you test it is you can open up another browser and then paste that link in. If it opens up, if you have it as public, it should be able to see. So this is what people see when they look at my repository. Okay. So if you wanted to use the link, you simply just go to the repository, and then at the URL, you would be able to pull this link, and you can embed that onto your Google site portfolio. So that way, if I, or, somebody that's looking at your profile, if they click it, they can say, oh, I can take a look at the code, right? I can take a look at the documents. I can take a look at the projects that they were working on, etc. Okay, so that's a good way of tying different resources together on your ePortfolio. Okay, so the step-by-step instruction is here. There are tutorial videos online, but many of the tutorial video, I pull them from my classes, because it actually walks you through on how to set up Git with, with your Windows system, with your IDE, etc. So you can do it that way, where it's always going to be syncing. I had a student that did that, and for some reason it wasn't writing the latest version of his final project to GitHub, and somehow we miss the last edit. So when I got the program from GitHub, it was not fully functioning. And so, so there are some technical challenges and such. So what you can do is you should be able to test everything and see it, okay? Now, on a little bit on the Google sites, when you set up your ePortfolio, and the ePortfolio is required for your project, it's yours to keep, so you can add in other types of project for your other classes. But in the part 3 of this, you will do a self-evaluation or the team evaluation, and then you would create a Google site. So on if you make a new site, you simply just click the link and then follow the instructions that you've read there, right? You can just start with a blank one, or you can use a template that they would have for portfolio. So I normally just do a template, okay? As I did one right here, just a brief one to show students, okay? So you can, change this picture, you can link it with your drive, you can use text box, add images, you can embed, and then you can also change the layout of it, okay? So everything is draggable, clickable, it's very easy to use. So I participate in a project with MakerEd. They help build the makerspace and such. So this is the profile that I created for the MakerEd, right? And you can also add different tabs, different pages to this. So you can have like different projects. For example, you have project for different classes, and it will look really nice. So in the pages option here, right, you can have the home, and then you can name your pages. So let's say I wanted to add like my English writing class, I can do that with the pages, okay? And so you can manage your pages and add, different themes to it, so it would look like how you want it to look, okay? The colors that you like, etc. So, and then when you're done and you want people to see, you can click publish, right? And so you can put in something like this, they would give you an example, right? Or if you want your name, if it's not taken, you can also use that. Once you click publish, it will give you a link, and you can use that link to submit for my class and also put on your resume. so that way people can see your e-portfolio so they can check out. And I would maintain it. Think of it like a digital portfolio where you can showcase all your work in all classes. You should not just keep it for, you know, technical classes. You should put other classes too, because employers, they look for other soft skills. So if you volunteer, that's a good thing. Put a page for that, take a picture, put it in there. So it's a good way to really market yourself and using free products like this, okay? So when you complete your e-portfolio and put in your project information, I want you to submit the URL of your e-portfolio, right? And I wanted to see how you use that, you add your project to that. And this is a good beginning for many of you just to, to have it. A lot of the university now, they require this and they have their own product, or, they would use something like Google Sites, and you can maintain it over time, and that will lead to professional careers and such. And so that's important to think about as you transition through different phases in your education. Okay, when I finished school, nobody taught us how to do this, right? Back in the day, you just searched the newspaper for work. Like, they didn't really teach me how to look for jobs and things like that. And I said, if I ever become an educator, I want to make sure that my students are going to understand some of the process, because it's highly competitive. So tap into the resources, make yourself more visible on the web, professionally, of course, right? Participate in LinkedIn Learning so that way you can earn some digital certificates and such. So that kind of make you more well-rounded as a professional, because, professional development, you should always continue to learn, as a student or as a professional. Okay. So that's just a little brief thing. And this part of the project, I will grade it based on, your completion of the e-portfolio and the team evaluation. Okay. And so any questions? Okay. So next week, no required Zoom session, the 16th through whatever. If you want to meet with me, send me an email. Okay. The following week, Thanksgiving week, no school. Okay. We're going to meet again on the 1st and the 3rd for final review. I will give you this week off again to get your project and your assignments, everything completed, right? And get ready for the final. Your final exam will be on the 17th. Okay. It will open that morning and it's going to close at 11:59. Whatever you do, right, take some time to take the final exam. Okay. My class closes that evening, and then that way I can get your grade to you. If you have any complication or challenges, make sure that you notify me, right? And make sure that we prepare for that. And so any questions, any concern? Okay, type in your name in the chat and I will stick around for a few minutes to answer questions. I want to thank you for a great semester. This class has been awesome with attendance. Everybody is participating. And I look forward to the next time I see you in the final review. Look out for the quiz, work on final review and the project, and post discussion this week, okay? Have a good night. Good night. Bye, Albert. Good night.
Thank you, Professor.
Bye. Have a good night.
Hey, Professor.
Yes.
I just have a question on the test. Is there a way we could take the test earlier?
when did you need to do that?
It's just I find, I have other classes too. So I was just wondering if it's possible I could take it on Tuesday.
Maybe I'll do a poll. I can
Mhm.
activate it only on Tuesday.
Mhm.
Yeah, the reason why I picked the 17th is only because, it gives you a little bit of extra time on
Mhm.
the course project.
Yeah.
But yes, so yeah, if for a specific request, I can actually add you for a different due date
Mhm.
on Canvas for that individual one. Just send me a reminder
Okay.
because sometime I forget. I usually don't, but just in case. Yeah, just send me like the week before to say that, oh, I talked to you about taking the final early. I like for the test to be activated. If not, I can activate the final on Tuesday and then have the project due on the other day. But yeah, for you, yes, you can.
Okay, thank you so much. Yeah, it would help me out, for my other classes and
Yeah, and sometimes students tell me that their physics class test is on earlier in the week, so I try to hold it later in the week, but then,
Mhm.
to satisfy 30 something it's
Yeah,
kind of
no, I
difficult.
I understand too. Yeah, I'm also taking physics and calculus and English right now, so it's
Okay.
a
Yeah,
handful.
if you guys want individual tests to be activated, it would
Mhm.
just be for that day. So just send me an email and then I can individually add the student for the
Yeah,
different date.
I'll send you a reminder a week before, and I'll also talk to my other professors too to see what I can do, and I can let you know what I could do.
Yeah.
Okay.
Whatever you decide, no problem.
Okay. Thank you so much. Really appreciate it. Have a nice
You're
night.
welcome. You
Bye.
too. Bye. Braxton, do you have any question? Okay, Braxton, have a good night, okay? Take care.